Okay guys, so this is question number 24 and is covering section 6.3. all right, so it's the center limit theorem. Okay, so again, please pause the video, all right, read the problem, identify the keywords, graph it, and then try to attempt it on your own. Okay, all right, I hope you get the answer correctly. All right, so let's see how can we solve this one, right? Okay, so the keywords here, so he's talking about the lifetime of the cellular phones. So he's telling you the average of it's going to be 24.3. all right. He's telling you as well the standard deviation is 2.6. Standard deviation here is 2.6. So, and up to here, we are talking about a regular normal distribution. We did not do the center limit theorem yet. All right, how do you know that you're going to be using the central limit theorem? Is actually this new sentence, the next one. It's telling you that we provide 30 employees. All right, so the 30 employees over here, this indicate we are already doing the sampling, and the sample size is equal to 30. All right, so now the question is, find the probability that the mean life of these phones will be less than 23 months. So that's the question. Now, although this is saying the mean over here, all right, but the mean and the average over here, they are not the same. So I'll try to explain it on the whiteboard. All right, so they write the probability in mathematical way, which is nice. Is the probability parentheses x bar less than 23 months, right? So keep in mind the average is 24.3, the standard deviation 2.6, and the n is 30. So let's go to the whiteboard. So before I forget, the mean is 24.3. The standard deviation is 2.6. The n is 30. And the x bar 1 is going to be 23. All right. So let's try to understand what's going on, right? So here, this information that you got, the first two, all right, so let me back them up, is related to a normal distribution. So we have a normal distribution. All right. It doesn't have to be normal, but it happened to be that one of them is normal. All right. This normal distribution here having the mean equals to 24.3 and sigma is going to be equals to 2.6. So now what we're going to do, we're going to take sample size, sampling, all right, and the sample size n equal to 30. So what we're going to do, we're going to take every 30, we do their average, and then we build up another histogram. So here you're going to come to play the central limit theorem. All right. So what is the central limit theorem? Is telling you that the new graph, whenever you do the sampling 30 at the time, is going to be as well normal distribution. However, here we used to have one data at the time, which is called x. Here we have 30 data at the time, which is called x bar. So that's why we call it average, right? So the mean sampling average. So you're going to have as well a mean, which is, we kind of call it mu, but because we are in the x bar, we call it mu x bar. And you're going to have a standard deviation as well, the same way, sigma x bar. So what the central limit theorem is telling you, besides is normal distribution. So is no, the central limit theorem is telling you it is a normal distribution. The sigma x bar, the mu x bar, sorry, the mu x bar is in fact equals to the same mu, the old one that you have it in here, which is this one here. and the sigma x bar will be equals to the old sigma, which is this one, right? Sigma divided by radical n. And we know the values, right? So this is going to be 24.3, and this is going to be 2.6 divided by radical 30, right? So this is basically the central limit theorem over here. Now I can copy the values, 24.3. There is no need, I'm using the calculator, so I'm going to keep it as 2.6 divided by radical 30 without making any approximation or anything. All right, so this is my values. Now the question is, start here. So x1 bar is 23, and the question is probability of x bar less than 23. So in order to do this, all right, so let me make some room here. Okay, so in order to do this, the x bar is actually in here, right? So the location of 23, if this is a 24 in here, around 24.3, the 23 would be on the left hand side. If I am less than 23, obviously I'm going to the left side here. Therefore, I'm looking for, if I'm looking for the probability, I'm looking for this area bounded by that horizontal line, do the vertical line and follow through this. All right, so this is what we are looking for here. This the area that I'm looking for it. All right, so again, I'm going to use the calculator. So your calculator will require the mu x bar, will require the sigma x bar, will requires as well the upper bound. So this is going to be called x1 bar, which is 23. So this is my upper bound, and it will require as well the lower bound. The lower bound is going to be somewhere here. Of course, if you keep going all the way, this is minus infinity, right? So this is going to be the lower bound, which is minus 1 e to the 99. Okay, so now we have all the tools. We can use the calculator. So let's go to the calculator. All right, I'm gonna go to normal CDF again. I'm looking for the probability. So second, distributions, you go to the second option, normal CDF here, enter. So those are the results from previous questions. So I'm going to clear it. So the lower bound is -1 second function, comma, that's going to give you e, and type in 99. So that's the symbol of minus infinity on the calculator, right? You're going to go to the upper bound. Upper bound is going to be at 23. All right. You're going to go to the mean. The mean is 24, cleared. So you're going to be 24.3. And then standard deviation, clear it first. And that's going to be 2.6 divided by, and then second and squared, x squared. Here you're going to be 30. And then close the parentheses. Now you move on to paste, enter, and enter to get the result. So it's going to be 0.00308. So the answer is that area is equals to 0.00308. Remember, you need 4 decimal points, all right, 4 digits. So you need to round the 8. So this is going to be 0.0031, and hopefully this is going to be your answer. All right, let's go back and check it. So let's plug it in, 0.0031, right? And check the answer. All right, nice, very good. We are one more and we're done with the review, right?